Okay, I think I got everything. So let me bring up the screen. Let's start with slide deck, and then I'll take it from there. Um, so a little bit about me. Unlike what you said a little earlier, I am not so much into Splunk. I mean, I'm not a Splunk admin. I don't work from that angle. I am a data scientist working here at Betsio. And I'm mostly into building machine learning models and then deploying them in production and operationalizing that. Splunk is a tool that I've been working with for past few years, and machine learning toolkit is what I've used. And from a data science background, anybody from there, this session is going to be really helpful because it kind of bridges the gap between what we do in Splunk, operationalize things, working with operational data and the log data and all of it. And that is Splunk machine learning toolkit, which is the extension in the machine learning direction. And then bridging that gap to this outside world where extensively we work on building machine learning models and so on and so forth. So that's kind of what this session is going to be. And I really wanted to do this because I did see certain a little bit barrier for somebody not working in Splunk, but in the data science space, but coming into Splunk to bring in their models and then deploy things in Splunk. I just thought it'll be useful to put everything together. So let's get started here. So what we'll be going through in this session? One, the first piece is I'll be talking about Onyx. In a bit, we'll know what exactly it is. It's one of the integral piece that I'll be covering through in the session. How that Onyx bridges between Splunk machine learning toolkit and data science that is outside of Splunk. And then next, I'll be taking this Onyx and putting it into 5-step repetitive process, which the framework which aligns with every machine learning or data science job that we do. Train, convert it into Onyx, and then deploying it into Splunk. I'll be getting into that detail, and then we'll be transferring and looking a little bit into enterprise stack of machine learning. What are the different tools enterprises use when it comes to machine learning? How Onyx fits into picture here? How Splunk fits into picture? And in general, what are the process that teams and companies follow in the field of machine learning? And all these different pieces, I'll wrap that together and we'll jump a little bit deeper looking into a use case. Here, the use case that I picked is predicting BGP. What BGP is also will touch on that, but it's here the important key piece is predicting a failure that happens in the infrastructure in the future. So this prediction is done by a machine learning model, and how do we deploy that and productionalize in Splunk? That's what we're going to cover here. So let me get to the next slide. And you guys feel free to jump in anytime. Any comments, thoughts, questions, always welcome.
So, in the next slide, you said like, is it a like open source machine learning model, or is there?
No, it's a file format. For sure, I'll be covering more details and about that in the coming slides. It's it's abbreviated as Open Neural Network Exchange, and it's a file format basically. I'll be getting into that. But before getting into this work Onyx, why we even need that? Why this session is about this particular slide? Here are certain things I thought is critical to frame before we get into details. One is the first category that I see is algorithm ceiling. Splunk machine learning toolkit is great. Out of the box, you get so many machine learning algorithms that come as packaged into this app as an add-on you can bring in, and then in Splunk you can use the apply command and just go about using those algorithms. That way, it is great. But things hit a ceiling when we don't find a custom algorithm or extension of a particular field, and be with classification problem or any machine learning problem, basically an algorithm that's not natively available as part of Splunk machine learning toolkit, it becomes a little bit complicated to package this algorithm in a way that it talks well with machine learning toolkit and it aligns with the structuring of MLTK in Splunk. That's a complication. Easier solution is this Onyx. We'll get to that, but the key here to understand is what is available natively in MLTK is limited, and the data science space is pretty vast and it's dynamically changing. And sooner or later, teams that are doing machine learning will hit the ceiling. So let's keep that in mind. Second one is data ceiling. With that, what I mean is in Splunk indexes most of the time because of storage or be it any reasons, we just keep 30 days worth of data in the index. So those sort of constraints could be there. And then now with the evolution of data lakes, there are other data stores in enterprise which store historical data, could be 6 months or a year. And more often than not, we need historical data to train machine learning models. And in that case, I see pretty applicable to train the model where the data resides, data lake outside of Splunk, and then bring that trained model to Splunk. So that's the second data category that I put in. And the third one is governance. What I mean by that is in the field of machine learning, it is very super important to understand how model is doing after it is deployed. With time, what are the changes that is happening in both model prediction in the environment, and just keeping an audit trail of what's happening, and then see if the model has to be retrained. There are so many triggers. We'll be discussing about that. But putting everything together, let's just call it as ML operations. So there are other governance things that we need, and different tools are great at doing that. How do we leverage all of those different tools which are expertise to do model versioning, and so on and so forth. So using different tools, packaging them with a data science model, and then bringing it to Splunk. That's another advantage that I see, and that's um, hitting the ceiling limit um, here. So yeah, those are the problems I just spoke about. There are many other things, but those are the pretty important ones. And another key, ML world and Splunk world. I just want to differentiate here in a sense that earlier I was telling I'm more from the data science background. I'm pretty well versed with things over here. And then we have Splunk experts who are great with SPL, alerting dashboard, and operationalizing and all of that. So how do we bridge both of these worlds when there are mature data science teams which are not working in Splunk, but we want to bring that expertise into Splunk? So this wall is kind of connected by Onyx. Onyx is Open Neural Network Exchange, and right now we'll just understand that Onyx is the bridge between ML world and Splunk world. Getting deeper into Onyx, a question so far, anything? Okay, I'll kind of get going. So yeah, the question that you asked earlier, what is Onyx? Just want to put it real simple. Let's just call it, it's a PDF for machine learning models. Um, by PDF, I mean anything that is in Word or Google Docs, we can just convert it into PDF and then take it forward, right? So here Onyx is a open source, open standard format of saving machine learning models, and then we can take it to another of machine learning framework basically. So it sort of makes the model building tool agnostic. And with that, what we really can do is, let's say I train my model in PyTorch outside of Splunk, and then from PyTorch, I want to move into Splunk, convert my model into Onyx format, and then bring it to Splunk. Here we can do that because Splunk's MLTK speaks Onyx and it accepts Onyx formatted file so that this model, which is imported into Splunk, can be used like any other model that is natively available in Splunk machine learning toolkit. So that's the key, and that's the ease of using this Onyx. Here at the bottom, if you see TensorFlow, PyTorch, these are all different frameworks used in the machine learning world. Build your model there, convert it into Onyx, and then take it to Splunk Machine Learning Toolkit. That's kind of what Onyx does. Talking a little bit more about that, there's just develop your model, export it to Onyx. We'll be taking a look at how exactly to do that and how to bring it into Splunk. So exporting it into Onyx, and then there's another check that I want to place. We'll be talking more about this. So here, after you convert your model into .onyx file, run certain checks to make sure this Onyx file is not having any issues, and make sure it works with Splunk Machine Learning Toolkit. That's the check I will be for talking about it in a bit in detail, and bringing this Onyx to machine learning and then just using it with the apply command. So yeah, it's as simple as that. This development side of machine learning model, if the Splunk team is not handling that or is not trained in the data science world, you could leave that to just the data science team, and then rest everything can be operationalized by Splunk admins and so on. So that's the beauty of this whole thing. Now I want to jump a little bit further to bring this picture of this. Here I've simplified things of converting to Onyx and then move it to Splunk. This process, I want to put that into an enterprise workflow for data science. So here I want to call this as ML pipeline. So if we want to productionalize these machine learning models, here are all the different things we have to be considering. So first one, connecting back to what I said earlier, historic data is not available in Splunk. One of the reasons why we want to go there, or just the data is available in data lake. Pick that and then train your model. Over here again, there'll be data pipelines connecting to our machine learning framework. Could be anything here. And then this is the key, which I did not talk about so far, that is tracking our experiments. The models that are being built, they'll always go through iterations. And then every iteration, what is happening, it is key to track if you want to go back. So that's where ML Flow is one of the open source tool that is great at doing this job. There could be alternatives. So here, what we see here on screen, Databricks, Azure, these are all different tools. This whole stack would depend on different enterprise, whatever the enterprise is using. But in general, this flow is going to remain the same. So build the model, track the model. Here, Onyx artifact, we can see here, right? So here, after building the model, track it, register the model, and then save your Onyx file, and then take the Onyx file and then bring it to Splunk. And the other important piece is this monitoring of what's going on. And then after monitoring, get it back to machine learning, where if we have to retrain the model and take that forward. So, um, yeah, and this experiment tracking, model registry, monitoring and retraining, this entire process together really converts just deploying machine learning model in MLTK to operationalizing the process of building model and then deploying it and then retraining the model. And that's the critical piece, and that should really be the way we should take forward machine learning, and be it in Splunk or anywhere. So that's that. So let's get into a use case, and then with this use case, we'll dive deeper into looking at how all of those different pieces work, the things that I spoke of so far. Um, okay. Yeah, another quick stop. I think so far. Any questions or thoughts?
So here you are training some model and you are pasting that into the machine learning tool GitHub, right? To use that in future purpose.
Right. Yeah. And that's the general theme basically. And then here with this use case, we'll look at the training side and also the deployment side, and how both work in sync. And again, taking things back to the training side from Splunk if we have to retrain the model. That's going to be in this use case. But yeah, you're right. In general, we'll be talking about training a model outside of Splunk and then bringing it into Splunk and operationalizing it.
Okay, thank you.
Okay, so let's talk about this use case. I just picked this because briefly I was working on this and I thought that's a pretty simpler model from the data science side, the machine learning side. Um, so I can just use that and concentrate more on the integration and connecting it into Splunk. So yeah, BGP. BGP is Border Gateway Protocol. Here we are using a use case on the network side, critical to every organization, because this is what really defines how network traffic sends information from one endpoint to another endpoint. All the routers, everything come into play here. And if this something goes wrong here, it essentially breaks the network connectivity. And with network infrastructure affected, it's going to cost the company. So it's a critical issue if gone unnoticed. We're here with this use case. We want to look at data and predict this BGP outage happening. That's kind of what we'll be doing. And then if you want to talk about what are the common failure points that are associated with border gateway protocol, it's generally session drop, this router flapping, BGP flapping. Generally that happens with any routers that has issue. Neighbor reset is adjacent to the router, then hardware degradation, just high level things in there. But yeah, key thing to focus here is this. Uh, can we build a machine learning model from past data around this BGP so that this model understands what has happened in the past around a BGP failure, and if it can predict a BGP failure happening in the next 4 hours. And that way, we'll be stepping from reactive mode to predictive mode, meaning 4 hours ahead prediction would give some time for the support team who will be receiving alerts from this whole process that we are setting up from Splunk. We can send alerts to ServiceNow or any other event management tool, and then to support team. So just taking right action proactively before degradation happens in the infrastructure. Um, that's really what we are trying to do here. So let's start with modeling side. How to build a model. I'm gonna just touch on that really at a very high level. How a machine learning model can be trained looking at past data around BGP, and then we'll take that further into bringing this machine learning model into Splunk. So here, model features. By that, what I mean is the metrics that are critical to look into a BGP failure. Um, so just gonna go real quick here. These are all different metrics. First one is coming from Splunk logs, let's say. BGP state change, neighbor reset. These are all the things that are critical to be watched around this BGP issue. And then there is device health coming from performance monitoring from different tools. And then there is this third category of CMTP, I'm calling it, but it really it's looking at different routers, how new or old that router is, what's its uptime, and then are there any past incidents around a particular host or device. So that's that category. But really, this is all that goes into model building, and then data science world, we just call it as features, when that will be used for modeling. So that's that. And then here, connecting back to what I was talking earlier, training, convert, validate, register, and operationalize. Well, I'll just be talking about these things, and then we'll switch gears. So here, for this demo, I'll just be switching to a different environment. Databricks is what I'm using, and that's where the model building happens. And then use a particular library to convert this Onyx, which I told earlier, test Onyx, and then in ML flow, use it to track these models, and then bring it to Splunk. And then at the end, I'll also be connecting things to ServiceNow, because ServiceNow is where the ground truth really is. After a model predicts whether it did a right thing or was it a false alarm, that's really where we'll get to know. So we'll take a look at that as well. Right. So yeah, I'll just get into this Databricks environment. Yeah. So now we are talking about the model building side, and then we'll go to Splunk. Um, so, yeah, for this demo, it's just some synthesized data that I'm using, which is already pre-run this particular notebook. Let me get into this pre-processing phase. I don't think I want to get into this test training split. That's just a step in machine learning side. Pre-process your data, make sure it is all clean, there are no missing data, and then split your data into test and training set. Um, the data could be 6 months long. Here for the BGP, let's say for the last 6 months, we are getting data across 50 routers. Every 4 hours, spin that and call it as a different data point, and then keep this 4 hours of data rolling every 15 minutes, and all of that comprises as your data really. So let's just take a look at the data that we are working with. Um, just 50,000 record as a sample I'm picking in here. And then in that positive is failures. There are just 250 failure points. That's when some issue with BGP happened. And then there are rest of the data points, and this 50,000 are negative. When the device was healthy, everything is good. So the ratio between positive and negative is 1:200, which is pretty high. That's a problem in machine learning world, and different ways that will be handled. But here are all the input features, which I was previously sharing on the slide deck. So state change is just a count. Every row here is for a host and for a particular time. So in last 4 hours, was there any logs around state change recorded? And then so on record CPU utilization and everything for that particular host at that time for last 4 hours, and then that will be correlated with whether there was a device failure in the next 4 hours. If yes, then that's a positive flag. This that will go under this 250 data points. If no, then that will stay in this other data points. So that's the data that we are looking at for this machine learning training, basically, right? So with that data, we got to take it through this pre-processing step. Um, Pre-processing is where we filter out any issues with the data, like missing data, and then splitting data into test and trainings for any machine learning model. Just 50,000 sample data points, we would want to split that into 70-30 ratio. 70% would be used for model training, and then use 30% for testing the model that has been trained, how it is performing. That's this test train split. Just scan through it, features, statistics. I won't go into that. That's critical, but at the later stage, I'll get to that. Another key important thing in the machine learning side is this handling class imbalance. Any problem that I would say from us working on the Splunk side, looking into infrastructure issues and so on, will always run into this class imbalance problem. The class imbalance is this piece, what I was pointing earlier, the ratio of positive or failure just being 1 is to this 200, 49,000 of the times where there's no issue. So that's imbalance, and I'll be sharing this notebook. There are ways to handle this imbalance. That will be part of pre-processing that happens in the machine learning world. Um, I'll just skip through that, and from the after this pre-processing, we'll get into modeling stage. Going back to the PPT, I just covered all of this here, imbalance and then how we handle imbalance, right? Let's get into this model building stage. Here, for this purpose, this use case, I'm just using a simple neural net model that is trained on TensorFlow using Keras package. Neural net is the core integral part of deep learning, which sits adjacent to machine learning, right? So this is pretty critical. I just simplified it to have a really straightforward, clean architecture. I'll not get into details of it unless you guys want to, but I still had this slide on here if people from machine learning background were on the call. But yeah, the content's gonna stay within the slide and also in the notebook, both of which I'll be sharing. But this is all around model building and choices that a data scientist makes to build a model. Right, so here in this code, it'll be there. I'll not go into detail. This is all again model building side. This is the architecture for this particular model that is built. And then this is this place. It's about training the model. And then the next important piece is evaluating the model. All of this just happens in the data science world, right? I'm not entirely sure if on how much flexibility we have in Splunk machine learning toolkit around this model building, changing features, parameters. If I go back here, this is just an optimization technique. Can we easily change that? I don't know, but here, for someone who is working with Python, it's and in the field of data science, it's going to be much easier to just keep the same language going, do your web model building, and then taking it into Splunk. That's really reason why I started looking into Onyx. Anyways, getting back here, so model building, don't want to get into details of that, but the next important piece is looking at how good your model is performing even before you bring that into Splunk. That's model results. The same thing would go on here. Basically, model evaluation. Let me just stick to the slide. So confusion metric is this thing where we are sort of seeing how the model performed. So here, if we see actual values are what really what happened, since this is the past data we are using for training, we know what the actual values is. This is vertically, this is the predicted value. So around 15,000, 14,900 data points uh, actually was healthy in the past. If we look at last 6 months, and then our model predicted it correctly as healthy, meaning no BGP issues. On the other side, if we look at this quadrant, this is where there was a BGP issue, actual risk, and then our model predicted it as risk. So this is good. We ideally want all the numbers to stay into these two quadrants, but that rarely happens. And so there's always this imperfection in the model. And this one would be where our model performed as predicted as healthy, but there was an issue. like missed failure. This is essentially, and then this is false positive alert coming from the model. There are 25 alerts that would go out wherein there is no issue, but then we would still send an alert. Um, but yeah, this is just performance of the model, and these are all different metrics. And the CF2 score is between 0 to 1, close to 1. It's performing really good. Just looking at all these metrics, this is performing very well. We can take this forward to Splunk. So let's push further into Onyx space from model evaluation. Until here, everything was mostly data science related stuff, building your model. And then let's look at Onyx, how to take our model to Splunk. Okay, so once the model is built, I am saving the model as .onyx format. So this is the model that is saved here. Now I'm working in Databricks space, could be any other space, even if it is a local Python notebook. Somebody is working on, they can always save the model. And then here's where Onyx resides. So earlier I mentioned that my framework here is TensorFlow and Keras, so I'll be using this particular library to take through the Onyx. Really important piece is while we are saving a model into Onyx format, the input features, this slide that I was talking about before, the names of these features that we put in here while saving the model and the order of these features is really critical because that's the same names have to be used in Splunk side also. Field names have to be very similar before it goes into the apply stage. So that's something that has to be taken care while saving the model. And other things that are really important at this stage is offset. Offset, I would say, is just a version. Just we got to make sure the offset that we use here is compatible with the machine learning toolkit that is being used on the Splunk side. That's another check we got to make. And then after that, if we would run, we'll get this Onyx model. So next step is taking this Onyx to Splunk, right? There are many ways we could do that. The most simplest way is going into machine learning toolkit. That's the app I'm in right now. And then if we go under model, upload Onyx model, that's the most easiest, straightforward way. We would just pick our model here, and then the key is just add that model, and you got to give a right name here, and that's to be matching with this Onyx file basically. And then feature name, that should be ending with exit names. Feature variables, earlier what I was talking, just make sure all of that is taken through. Exact same features have to be there, comma separated and no spaces in between. That causes problem. And then target variable is a output field that Splunk would uh, provide the result. And these are the critical things that are required to make sure when we bring in this Onyx model to Splunk. Right now, I'm just showing this way of uploading model, but in production, what we essentially need is an operationalized way of sending this Onyx model from here, Databricks that I'm using, to Splunk. So I just showed you guys the first piece here, manual, but this is what most mature teams would go for, sending it to through a REST API call. Splunk does take in that. And machine learning toolkit through HTTP provides lookup file. So that basically this Onyx file will go in as a lookup in this machine learning toolkit. And that's how we can really operationalize once the model is built. Just use Splunk's REST API and do a post with required information. The information is same as what we are seeing here. All of this would be part of the payload, and make sure that goes to Splunk. And that way we have our model inside Splunk. So I've already brought the model here in the Splunk environment. So I'll just show here how to work with the model. So far, anything. Uh, okay. All right. So I'm just making some results. So here, these are all the same features that the model was trained on. And then these are the values that the model was for this data point, just creating these values here. And then this is the piece where we are inferencing the imported model through Onyx. So the way we would do is this apply is what we use against any other model that is here in Splunk Machine Learning Toolkit. We would just need this precursor of Onyx and colon, and then this is the name of the model that we use during applying, or could be a REST API call as well. But yeah, that's a reference to your model. Right now, I'm running here in machine learning toolkits. This is good. If we want to reference this model in any other app, then we should also add app information. But yeah, that's simple things because prior to here, this could be all our SPL where we are searching for all this data that resides in different index, and then just use this apply command. Will just have results here in Splunk. So essentially here at this point, what we have done is trained a model outside of Splunk, here in this case in Databricks, and then we have brought that into Splunk through Onyx, and then I just used it for inference for just one data point with a little bit looking into further. So here, this is the prediction that the model made. Failure probability is 0, saying for this data point, these values, we won't be having any issue with BGP, and then that's the probability that it's saying. So if this SPL had many rows here, every single row would have a prediction coming from this model that is trained outside of Splunk. That's what we have been building to so far. Where was I? So yeah, I did cover this converting to Onyx, and inference is what I just shared as an example here. And then the next critical piece would be monitoring here in Splunk. Then this is really what makes until now what we have done is deployed a model basically, but this structured monitoring is gonna make that deployment be productionalized, where we can send out all these predictions that we see here in Splunk to another tool service now, or basically to support groups who will take action based on the prediction that we are making. Right. So there are all this different monitoring that are essential. I'll not get into each of it. Drift is a keyword here. Drift is essentially talking about the deviation that is happening from our training perspective. Did the data change? We have trained on a particular set of data, right? Last 6 months worth of data. It has current data changed from that, or is there environmental change, or did any infrastructure event happen that is pushing our inference or production environment away from our testing? That those are kind of the monitorings that we need to deploy, and all of this can happen in Splunk. I just have a dashboard on that. But with this monitoring, we really are doing this retraining to look for those data drifts and then send the information back to Databricks, here in this case through a webhook from Splunk, and then retrain the model and then push it back to Splunk through this REST API. So that's this loop. Let's take a look at this dashboard here in Splunk, which really does this monitoring. This is that confusion matrix that I was talking about earlier. That is used against data coming in from an index. These are all device, and this is the outcome. Um, that is cause, and this is the drift that I was talking about. Um, this is live CPU over different time, and then this is the baseline. We got to monitor how it's changing from the baseline to its current state. If it is moving away, and then that movement is beyond a set threshold, we know our current production data has changed significantly from the training data, that essentially would need a retraining basically. And this monitoring should send an alert from Splunk to Databricks. Could be through webhook. There are different ways to do it. Um, yeah, that's something that to keep an eye out for after a model is deployed. And here, I think this is just how our model is doing against ground truth. Ground truth here is what happens in service now after we send an alert, after a team acknowledges that alert. Was there a real issue, or was that a false alert? That information has to be brought from service now. So this data is dependent on input from service now after we deploy something. And then these are the places where our model failed, because ground truth was 1, meaning there was a BGP failure happening, and then we did not predict that. So it's really important to monitor this as well. And all of this really comes down to this particular slide, which talks about closing the loop, about more about when we should be retraining the model. The service now lookup that I was showing on the dashboard, that really stays here. um, yeah, kind of putting all this monitoring in place is what really operationalizes a machine learning model. So here I did cover a lot of things. We started off from what is Onyx, why it's needed, and we really quickly looked at building a model in Databricks, an environment outside of Splunk, and then converting that into Onyx format. And then we wrapped everything with deploying it in Splunk for inference. And then last few slides is all about after what happens after you put a machine learning model in production in Splunk, the key monitoring that is required so that our machine learning model is always relevant. So yeah, those are all the different things that really make um, machine learning model an integral part of Splunk. And then I just think we gotta extend things beyond Splunk machine learning toolkit for the reasons that I was talking about right now. Yeah. Okay, I'll be sharing the slide and the notebook as well. You guys can just take a look at from what I know so far. Um, Ron, I'm not really sure if this is gonna help you so much, but again, depends if you're curious about what's happening outside in the machine learning world, how this training happens, then I think this is a good entry point where that yeah, the next demo it just talks a little bit about there are comments just talking about different pieces of machine learning model and yeah, just explore it. And this what Onyx really helps is all the content around data science that's out there. Even if somebody wants to get in, it's all in this language, and that's somewhere somebody can start learning. And just bringing all of that into Splunk could be through Onyx. So that's that advantage too. But yeah, I'll be sharing this Jupyter notebook as well. Okay. Tapas, anything, any question, or any thought?
No, Abhiraj, nothing as of now, but yeah, I think I need to explore it a bit more because this is something which is uh, out of my regular
Right.
day-to-day work and activities. So yeah, so once
Yep.
I get to explore more, then yeah, I might have something. But yeah, as of now, I'm fine. So yeah, that was a great session, man. Thanks.
Great, great. Nice. Yeah, so do find time to explore all this. If you have any questions, always feel free to contact me. Yeah.
Sure, sure. So you'll be sharing this in the email or how it is going to be?